The bisector of an angle is a locus of points in the interior of an angle equidistant from the sides of the angle. An angle bisector divides an angle into two congruent angles. The bisector of an angle is a locus of points in the interior of an angle equidistant from the sides of the angle. An angle bisector divides an angle into two congruent angles. So a diagram of that would look like, let's say you got angle ABC, and you run a ray that starts at B and it goes into the interior of this angle. And we'll put point D on it. So if angle ABD is congruent to angle DBC, then ray BD is an angle bisector. If ray BD is an angle bisector, then any point on that bisector is going to be the same distance from both sides of the angle. So point D is going to be the same distance from point A. So this segment AD would be equal to segment DC. I don't know. Alright, so let's write down these two rules as well. It's going to be a little bit repetitive, but I want you to have the theorems in your notes. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. The converse of that theorem. If a point in the interior of an angle is equidistant from the sides of the angle. Then it is on the angle bisector. Any questions about any of that so far? On page 327, we're going to do example 3A, B, and C. So example 3A, you are given a diagram that looks something like this. And X to W is 7 units long. Angle XZW is 41 degrees. And angle YZX is also 41 degrees. You're asked to find the length of XY. Alright, so since this ray ZX splits this angle into two congruent angles, then X is sitting on the angle bisector. And if X is on an angle bisector, then it is equal distance from both sides of the angle. So how far would it be from X to Y? 7 units, good. So there, you're done. If you're given this picture, and this big angle on the outside is JKM, point L is right in here in the interior of the angle, and L to M is perpendicular to the side of the angle, and L to M is congruent to L to J, then point L is the same distance from both sides of the angle. And if you're given angle LKM as 37 degrees, and you're asked to find the measure of JKL, then what would the measure of angle JKL be? 37 as well. Alright, if this point L is the same distance from M as it is from J, then it's on an angle bisector. And ray KL splits JKM in half. So these two got to be equal to each other. Example C. You've got angle MJP point S is right here on this ray, and you are told that the two smaller angles are congruent to each other, which means that M to S will be congruent to S to P. Because if S sits on an angle bisector, then it's the same distance from both sides of the angle. Well, then you're given the expression that represents MS as 3x plus 5. And S to P is 6x minus 7. And you're asked to find SP. So since the two segments are congruent, then the two expressions are going to be equal to each other. So your 3x plus 5 is equal to the 6x minus 7. And if you solve for x and substitute, you can find the length of SP. So subtract 3x from each side. And 5 is going to equal 3x minus 7. You can add 7 to each side. 12 would equal 3x. And divide by 3. So 4 would be equal to x. If 4 is equal to x, you're going to substitute. So let's see, SP equals 6 times the 4 minus 7. And 24 minus 7 is 17. Everybody all right with that? Look at the top of page 328. This in-center theorem is really important. It says the angle bisectors of a triangle intersect at the in-center. Which is equal distance from the sides of the triangle. So if you're told that a point is the in-center of a circle, it means that all of the angle bisectors meet there. And it also means that that point is the same distance from the three sides of the triangle. So let's look at a problem on page 328. You've got example 4. We're going to do problem A. Example 4A. So this picture that you've got, triangle ABC, find each measurement if J is the in-center of ABC. J is the in-center of triangle ABC. So you kind of, when you draw this, you're kind of trying to predict where these three angle bisectors are going to meet. And this is going to be point J. So you got C to J, B to J, and then A to J. Those three segments bisect their respective angles. Then along with that, you got a segment that goes from J to this side of the triangle, and that's point D. J that goes to this side of the triangle, That's point F. And J that goes to side AB of the triangle. The other given information is angle JBE is 34 degrees. Segment EA is 12. Segment JA is 15. So what you have to get out of this description here, J is the in-center of ABC. If J is the in-center, it is equal distance from the sides. So this is true. J to F is going to be the same as J to D, which is going to be the same as JE. What you're asked to do in this problem is find the length of segment JF. So you're looking for this segment right here. It's the side of a right triangle. But in that portion of the problem, you're only given the hypotenuse of that right triangle. So if you look at the triangle adjacent to it, look at triangle JEA. Triangle JEA is a right triangle, and you're missing one side of that triangle. And the side that you're missing is congruent to this piece JF, which you're trying to find. So since you know two sides of this right triangle, you can use the Pythagorean theorem to find side JE. So JE squared plus 12 squared equals 15 squared. So your JE squared plus 144 equals 225. If you subtract 144 from each side, then JE squared is going to equal 81. And if you square root both sides of that equation, then JE is going to equal 9. And since J to E is equal to 9, and it's congruent to JF, then JF is also equal to 9. Okay, so there's a lot of information in the fact that J is the in-center of the triangle. Alright, take a look at this angle right here. D, B, J. What would the measure of DBJ be equal to? 34 degrees. Because if J is the in-center, it's where all the angle bisectors meet. If this angle, DCJ, is 32 degrees, then what is angle FCJ equal to? 32 degrees. Good. If angle FAJ is 17 degrees, then what would the measure of angle FAE be equal to? Alright, good. If this angle up top is 17, then the angle below it is 17. And angle FAE would be equal to 34 degrees. Alright, any questions on any of that stuff? Angle bisectors, they're concurrent at the in-center. The in-center is the same distance from the sides of the triangle. Alright, your assignment for today is starts on page 329 again. Problems 5 through 8. And then over on the next page, 21 through 30. And please, if you haven't been doing it, let's get back to checking your odd answers every day. Check your odd answers every day, please.